Welcome. This is Convergence. My name's Attorney Michael Doran. I'm a California attorney. You can look me up, State Bar number 147697. I'm a public figure. Nothing to hide. I don't have a dog in the hunt. This is a Convergence. Today, as always, I'm talking about Albert Einstein's among the most difficult problems in all of physics, which I contend is among the most difficult problems in all of biology. So, what are the two areas that are converging? This time, we're going to talk a little bit about implausible complexity in early evolution, and we're going to talk about a seismic clock and how the science is converging. So, again, that little story, my mom having prayer meetings, which I don't think is a bad thing. Here, a local congressman, Doug LaMalfa, was saying that people who were impassioned about climate change it was like a religion to them. And at first, I really took offense to it. I don't respect him anyway, but that kind of comment, because I enjoy the debate over climate change, was offensive because it meant that I was religious in the most negative way. But then I started to think about it. I'm a lawyer, and I went through law school. I passed the California bar on my first attempt. I'm very proud of that. And it took a tremendous amount of effort. I remember being very burned out after a semester of studies and not being able to study very well at first. And I had to have what I call the sweet spot. You can call it a place to pray. I mean, and since I was raised as a Catholic, I knew what prayer was, and that ended up being a place that I kept sacred, and I would go there to study. And if I had any kind of negative energy, I would leave that place and only come back to it. And so when the energy was good, and so when the semester wore on and there was the grind of finals week, I still had a place where I could go and hold sacred, and I won't say force myself to study, but at least that I had the right mindset to do something like that. And when you take on a very difficult problem, like among the most difficult in whether it's physics or biology, it's going to take prayer. It's going to take your ancestors behind you. It's going to take standing on the shoulders of giants. It's going to take that kind of effort. And so the people, Mr. LaMalfa, who are starting to raise the concerns that are legitimate concerns about what's going on, yeah, they probably do have some religion in them. And that's not a bad thing. Okay, that's as political as I'm going to get. So one of the little things that we talked about from this book that my mom read when I was a kid was this idea of implausible complexity and the chance of first life coming together by chance. And one example, and I've seen this before respectfully among Christians who are not evolutionists or arguing against evolution, is they talk about handedness in molecules. So the idea is that if you do a Miller experiment and you have these chemicals of early life and you run some electricity through a flask, you're going to get a randomized amount of these chemicals, and some of them have a hand. And what I mean by that is a nucleotide will have a length, or a shape. It'll have a mass. It'll have a charge, but it also have like handedness. like a mirror image of it. So it could be the same chemical, have the same mass, have the same length, but one is left-handed and one is right-handed. So the human body, for instance, there are some vitamins that you can take that are really good for you that are if they're left-handed, but they're poison for you if they're right-handed, because the way the body ended up being put together is with the left-handed one and not the right-handed one. So how would these chemicals flying together come together by chance? Was it just a chance at the left-hander, and did that chance action occur over and over and over again? It just seems like an implausible complexity. And this is where cloud sorting comes in, where you have nucleotides that are in a supercooled droplet, and as that droplet is turning to ice, it's going to turn into ice in the electrical fields, depending upon not just the mass of the molecule, the length of the molecule, the makeup of the molecule, but also the handedness, because it's going to affect how it turns, how it migrates, and then what the shape of the ice lattice that's forming is, and then how fast it freezes. So again, the molecule can be both a model for what life is for future generations or future replications, but it also can be, most importantly, a feedback. So the dualism is what makes DNA so interesting. Carbonation is also part of what functionally does the modulating or dampening now, as life has become more complex and is out of kind of the environment that initially was in. Because life has become more efficient in cells, and there is some vestiges of this past, like virus host, sperm egg, spore egg. There is some vestiges that evidences this process and this symbiotic relationship between cellular life and life that actually could get in a droplet and do some cloud modulation. But there's also this dualism, the symbiotic relationship between carbon dioxide and nucleotides, and it's why we're all carbon life, is because CO2, carbonic or carbolic acid, DNA acid, RNA acid, all were part of how phase change occurred in supercooled water in the context of these large-scale electrical fields. All right, so let's now shift over to the other end and talk about another implausible complexity and see how it's connected, and again, see how the Earth's magnetic field is really a living system. I'm going to read a story that's out of IB Times SG. That's an Indian internet story. It's dated November 6, 2020. It's written by Jivan Biswas. It's entitled "The Earth Pulsates Every 26 Seconds. Why?" Known as a microseism, the Earth pulsates every 26 seconds, and the cause of the seismic activity is a debated one. The internet link is ib.times.sg/earth/pulsate/every/26/seconds/scientists/contend/over/it does/53112. So he's citing a paper by Jack Oliver that documented a microseism for the very first time. He deduced, I'm quoting, that the pulse emanated from somewhere in the equatorial or southern Atlantic Ocean. Oliver also noted that the pulse was more powerful during the summer months in the northern hemisphere at a time when it was winter in the southern hemisphere. Okay, so let me first start out by the intertropical convergence zone. By season, it moves from the thinner part of Africa up to the wider part of Africa. It actually then it goes up across the ocean to the wide part of South America, and then gets up into South and Central America. And there's a kind of a double peak of lightning that occurs in the springtime, and then into the fall too, as the Atlantic Ocean heats up and becomes more conductive. The oceans are more conductive, saltwater, the warmer they get. There's much more lightning in the northern hemisphere because there's more land in the northern hemisphere. So right away, we have an electrical clue, a lightning clue, a global electric circuit clue to what's going on here. So the article goes on. Mike Wolitzer, a seismologist at the University of Colorado, told Discover, Jack didn't have the resources in 1962 that we had in 2005. We didn't have digital seismometers. He was dealing with paper records. Wolitzer himself would go on to have his own encounter with the phenomenon a few decades later. Nearly 20 years after Oliver's study, Gary Holcomb, a geologist with the U.S. Geological Survey, took a closer look at the tiny shakes in 1980. He ascertained that during storms, the microseisms was the strongest. That was the last focused investigation into the peculiar and nearly unnoticeable quakes during storms. Well, so it's my view that tropical storms are the most intense electrical phenomenon on Earth when they occur. You get intense capacitive couplings, and they generate very strong fields, and they don't just generate fields in the area of the storm itself, but nor in the region with thunderstorms and lightnings around the storm. They use a tremendous amount of energy, but I also believe that energy profile goes deep under the earth. And it's just like a toaster. You pull a switch, and what's going to happen to that wire that heats your toast? It turns red. So there's not just electrical things going on. There's also heat things going on. And just like your electric car, there's also motion. There's kinetics to it. The storm is kinetic. So there's a lot of electrical things all interconnected here. And because it's a dampened system over time, this is what life had to do to modulate the Earth's magnetic field. If it didn't, we wouldn't exist here. We would be like Mars, or we'd be a hothouse. You can't, if the magnetic field is too strong, it's going to capture too many gases, and everything is going to cook. If it doesn't connect, if it connects not enough gases, if the field is very weak, then the atmosphere gets stripped away, and then everything dies. So the Earth's magnetic field has to be just perfect, and it becomes just like handedness in a chemical. It becomes just that right selection. It's selected. It's implausible that it would come to be like this by chance. It's something part of a selective process over time that got winnowed out, and this is just the way it is. And there you see examples of it all over the Earth. These implausible complexities, as things line up to effectuate the dampening that is occurring. So, as luck would have it, Greg Benson, a graduate student then, was asked by his advisor to present the seismic data that he'd been studying. An interesting discovery was made. He narrated that to Benson, and when he analyzed some of this data, he noticed a strong signal arising from a distant location. As soon as we saw this, then postdoctoral researcher Nikolai Shapiro and I recognized there was something weird. We had no idea what it was, said Ritzwaller, according to Discover. In fact, the team managed to even locate the organ of the pulse somewhere in the Gulf of Guinea at a distance from the western coast of Africa. The team looked into Oliver's and Holcomb's research and brought out a study in 2006. However, the confirmed cause of the pulse has not been unanimous. While some have attributed it to waves, others hold volcanic activity responsible. Well, it's neither volcanic activity nor waves. It might cause waves, it might cause heat secondarily to the electrical, but the pulse is fundamentally an electrical resonance. Locating the source of amidst the noise or seismic activity in the course of quiet times, the absence of volcanic eruptions or earthquakes is well known among the scientific community. Welshrow explained that the sun is the cause of seismic noise. A noise. This is not a noise. This is a resonance. As the sun tends to heat the equator more than the two poles, ocean currents, waves, winds, storms are created. Upon making contact with the coastline, the generated energy is passed on to the land by waves. Yes, but it's chaotic. It's randomized. That's the problem. That the Earth gets these random inputs, which it has to dampen. I can go outside and it's hot. My body temperature still stays the same. It's because I either sweat if I'm hot or cold I shiver. There's different ways that my body keeps its temperature in a healthy range. And this seismic clock is fundamentally a biological phenomenon. It's like if you were tapping on your desk, it deforms the area near your knuckle, but then it's being transmitted across the whole table. So someone sitting on the other side of the table, if they put their hand or maybe their cheek on the table, they can feel the vibration, explained Rutzweiler. Though such noise has been studied for years, Rutzweiler admitted that the 2005 was a Eureka moment for him. Well, maybe for him, but it's still wrong. It certainly is a repeated vibration that's occurring on a volcanic island off the coast of Africa, but it's right where the ITCZ is. It's where there's a tremendous amount of lightning that goes along Africa, and there's kind of a constancy that's obtained because the whole of the Earth's magnetic field is huge, and it has a huge amount of momentum. And if you have a conductive pathway to that volcano, and you're going to end up getting a resonance that over time is going to predominate, because it's really a resonance not just of the volcano, but it's ultimately a resonance of the whole Earth. And is there any proof of that? In the early 2010, Garrett Ruler, a graduate student at the Washington University in St. Louis, managed to further narrow down the origin of the pulse to the area known as the Bight of Bonny in the Gulf of Guinea. He posited that the seismic activity was caused by the impact of waves on the coastline. Again, wrong. In 2013, Euler presented his findings to the Seismological Society of America conference. Waves are volcanoes. Contentions and contradictions form an integral part of science. In 2013, Jingji Zhai from the Institute of Geodesy and Geophysics in Wuhan, China, and his team published a paper that suggested that the source of the pulse were the volcanoes and not waves. That is correct. But that's where it was. It certainly could be something seismic is a vibration. It's physical, but your car vibrates too, and it can vibrate every 26 seconds. But fundamentally, interesting, a volcano on the island of Sao Tama in the Bight of Bonny is situated very close to the origin of the pulses. Situated very close to the point of the pulse's origin. So what do we have? We have lava. We have flow from down. We basically have a conductive pathway. Also, a volcano now this is a key point. Aso volcano in Japan is known to cause microseisms that bear strong similarity to the microseism being discussed. Whoa. Okay, so you have on one end of the Earth, you have these microseisms, and then you have it on the other end of the Earth, same thing. And the thing that they have in common is a conductive pathway down into, and remember we're talking about with the Earth, it's a double domino. We haven't been able to model it, the double domino. We have a moving magnetic field, but we have lengths to the double domino down. and we have sources of current that are tremendous from a tropical storm standpoint, with the run from the Cape Verde Islands up into North America during the tropical storm season in the North Atlantic, and then in the Western Pacific, we have a tremendous tropical storm season as well. So you have these storms that generate huge amount of capacitive couplings. We have the Earth's. The other thing we have here too, it's also worth pointing out, is especially during certain times of year, charges will organize with the southern oceans. Most lightning occurs over the continents, over land in general, and there's three major continents where this lightning can occur, especially in the winter time, and then probably starting with the tropical storm season as well, because the Southern Ocean is a common. It's like a common ground. But you end up with these four areas of north-south lightning during the winter time. But during the tropical storms peak, it's fair to say that the Cape Verde Island run is the most intense, and then it's also fair to say that run in the northwestern Pacific up through Japan is also a massive place where, especially if you find a big tropical storm, you're going to have tremendous currents, and these currents and these fields that are created are going to be something that is very connected to the subterranean. You're talking about the rim of fire there, and then in Africa, you're talking about these volcanoes where some of the most intense lightning is occurring in the intertropical convergence zone. Despite larger discourse revolving around rhythmic pulse, there are other intriguing questions surrounding the phenomenon. For starter, why Baitabani? Why not any other location on the planet where there are several volcanoes and continental shelves? Yes, that's what I've been talking about. Unfortunately, the exact underlying reason for the pulse being generated continues to remain inconclusive nearly 60 years after its first documentation. We are still waiting for the fundamental explanation of the cause of this phenomenon, says Ritzwaller. I think the point of all this is there are very interesting fundamental phenomena in the Earth that are known to exist out there and remain secret. Perhaps another set of bright students in the future will be very successful at deciphering the puzzle, hopes Ritzwaller. And honestly, this puzzle needs to get out there to be talked about in terms of the electromagnetic field of the Earth is a biological phenomenon, and we're part of the biology. We're the stewards of this. We can stop interfering and destroying this biological wonder that keeps the Earth safe, and start playing along with it. Thank you for watching, and have a happy 4th of July.